When the Earth was just 50 million years old and still soft and molten, scientists think it was struck by something the size of Mars. The collision was a glancing blow, but 2 days later there was a second impact. This double impact could have blasted enough material into orbit to form our Moon. Within a year or two, there was a molten Moon orbiting a molten Earth, but 20 times closer than it is today. The gravitational pull between Earth and Moon was so strong that the Moon's rotation was held in a position so it always faces Earth the same way. That means each time the Moon orbits the Earth, it also rotates once on its axis. That's why, from Earth, we only ever see one side of the Moon. The Moon is 3,500 kilometers across, a quarter the diameter of Earth. The Moon's orbit is now some 384,000 kilometers away from Earth and takes 27.3 days to complete. As it orbits, the Moon appears to change shape as we see the phases of the Moon's lunar cycle. The Moon has no light of its own. We only see it when it's lit by the Sun. Here, the Sun is shining from the right, and exactly half the Moon is always illuminated. How much of this we see depends on the positions of the Earth, the Moon, and the Sun. When the Moon's lit side is away from us, the side we see is dark, and it's called the new Moon. When the side we see is all lit by the Sun, it's called the full Moon. The complete lunar cycle takes 29.5 days. The surface of the Moon tells us a lot about its history. The large dark patches are called seas. But these seas aren't water, they're great craters filled with lava. This is called Mare Imbrium, the Sea of Rains. Mare Imbrium is 1,300 kilometers wide. It was created by a huge impact. We can still see evidence of these ancient impacts even though they stopped around 3.9 billion years ago. Smaller impacts continued to pockmark the lunar surface, making smaller craters. But why are all these craters so easy to see after millions of years? The Moon has no atmosphere, so there's no wind or water to wear away its surface. The only thing to disturb the old craters are new craters. The youngest craters on the Moon are surrounded by material splashed out by the impacts. Mountains were thrown up around the rims of big impact basins. These are ancient lava channels. The Moon is much smaller than Earth, so its gravity is weaker, 1/6 that of Earth, and that's too weak to hold an atmosphere. When the Apollo astronauts landed on the Moon in 1969, they had to carry their oxygen with them, and they weighed only 1/6 of what they did on Earth. And with no air resistance, a hammer and feather fell to the ground at the same speed. With no insulating atmosphere, the temperatures on the Moon range from 120 degrees Celsius by day to minus 160 degrees Celsius at night. The astronauts had spacesuits to protect them from these temperatures while they carried out their scientific research. They used special moon buggies to get about during later moon landings. Scientists compared rock samples brought back from the Moon with rocks on Earth and discovered that some moon rock was very similar to the Earth's liquid upper mantle, but solidified as the Moon has cooled. Inside the Moon is a solid metallic core, but much smaller than scientists expected, only 1/5 the Moon's diameter, while the Earth's core is more than half its diameter. This suggests the Moon originated in a different way from the Earth, such as in an impact with another body. When it was first formed, the Moon was 22,500 kilometers from Earth. Today, it's nearly 20 times that distance and getting further away. We know this because of laser ranging. The Apollo astronauts left reflectors on the Moon. Scientists on Earth use them to measure the time it takes a pulse of laser light to go to the Moon and be reflected back. From this, they could work out the distance to the Moon to within 1 centimetre. Currently, it's some 384,000 kilometres away, and moving away by about 4 centimetres each year. This is because of tidal drag, the gravitational pull of the Moon on our oceans. Our tides rise in just over 6 hours and fall again in the same time, and it's mainly the work of the Moon. The tides rise and fall twice a day around the globe because, as it goes round, the Moon tugs the oceans into a bulge on either side of the rotating Earth. But the drag of this tidal bulge is slowing down the Earth's rotation, causing our day to get slightly longer and the Moon and the Earth to move slowly further apart. The Moon has another effect. It keeps the Earth on an even keel. What would happen if the Moon began to move away? With the Moon's gravitational pull at the Earth's equator reduced, the Earth would become unstable. Over millions of years, it would wobble chaotically and eventually keel over. Our climate would change dramatically. Ice would girdle the equator and for half the year spread far into the southern hemisphere, the side away from the sun. 6 months later, it would spread into the northern hemisphere while permanent sun baked the other side. This could be Egypt. For some of the year, the Sahara Desert could become a frozen waste. And Antarctica could become a blazing desert. All if the Moon's pull on our Earth were to weaken.